Now we move to our next topic, and this topic is black holes. When we talk about black holes, probably I'm very sure that you all have heard about black holes. And I'm also very sure that you have heard about the fact that black holes does not even let light escape from it. These are few of the things that we keep hearing about whenever it comes to black holes. Now, black holes in the scientific literature has been for more than 100 years now. Einstein's general theory of relativity was the first time when a phenomena like black hole was mentioned. Although in his theory of relativity he did not mention the term black hole, he just mentioned the phenomena. That something like this should happen. This is what he had said. What should happen? We'll have a discussion on it. Now, black holes, the name was given somewhere around 1960s. Now, when it comes to black holes, what exactly do we mean? The pictures that you see on your screen are nothing but artists' impression of the black hole. This is how it was thought that black holes would look like if we were able to capture it. But that was not to happen. This picture that you see on your screen now, this is the picture of the actual black hole that was for the first time captured by a telescope. I know it does not look as impressive as the artist's impression, but this is how the black holes look like. So, first of all, what do we mean by a black hole? What is the meaning of a black hole? And then let's go to the specifics of black holes. So, first of all, black holes are any region in space which have been created most of the times at the time of death of a massive star, where the force of gravitation is very high. The force of gravitation is very high, the pull of gravitational force is very, very high, and that's why everything that is in the vicinity, all the celestial bodies that are in the vicinity, even something like an electromagnetic waves also which are in the vicinity, nothing can escape the gravitational pull of a black hole. And that's why it has been named as a black hole. The name black hole suggests that this is one region in space which is black, meaning that it is dark. It is devoid of any kind of light. Why is it devoid of light? Because light is not able to escape this region. So that's why the light which is there in the vicinity of this region will fall towards the black hole. And that's why we cannot observe it. So first of all, why for so many years, although theoretically through our calculations we knew that black holes should exist, why were we not able to capture it? We were not able to capture it because the electromagnetic waves which are in the vicinity, they cannot escape black holes. So that's why if we are using an optical telescope, for example, then optical telescope use light. So since optical telescopes use light, light is not able to escape this region. You cannot see it. You need light to see anything. If you are able to see this lecture, you are able to see the lecture because there is a backlight in your tablet itself. You are able to see everything there in the surroundings, everything there which is in your room, only because of the light waves. So a kind of electromagnetic waves which are letting you see everything around you. So now, since black holes do not let the light pass through or do not let the light be or behave as they behave normally, that's the whole reason why black holes are invisible. It's not only about the light, it's about every kind of electromagnetic wave. For example, even if we are using an X-ray telescope, the X-ray telescope will also not be able to observe it, because even X-rays are electromagnetic waves and electromagnetic waves will not be able to escape it. So this is the basic theory behind what happens at a black hole. A region of very strong gravitational field, so strong that all the objects in the vicinity start to fall towards the black hole. Everything that is in the vicinity, including the electromagnetic waves like light waves, start to fall towards the black hole. So to summarize the points, black holes are places in space where the pulling force of gravity is so strong that even light cannot escape. Collapse of big stars causes supernova, which may result in formation of black holes. Now we discussed this. While we were discussing the formation and the lifestyle of a star, we discussed in the lifestyle that a massive star may convert into a black hole. Now this massive star may convert. We had two options there, correct? We discussed that either it can create a neutron star or it can create a black hole. First of all, which kind of a star will create a black hole, and when is it a possibility that a neutron star will be formed? Many times what we have observed is that if you have a massive star, by massive star what do we mean? We mean any star which is having a mass more than 1.44 times the mass of our sun. Now this star which is massive will not always form black holes. we see normally that if it is at a level less than 3 times the mass of our sun, then in that case most of the times neutron stars are formed. So black holes are formed only when the stars are more massive. Most of the stars that we see converting into black holes, these are stars which have masses more than 10 times the mass of the sun. So only these kind of stars are normally finding their way to becoming a black hole. So even if it's a massive star, the massive star which does not have huge mass will not convert into a black hole. So normally we see that black holes will be formed when masses of the stars are more than 10 times as compared to the mass of the sun. So these will form black holes. Now, after this, what we know is that black holes are very small in area but are massive. What does it mean? It means that the density is very high. What is density? Simple physics. Mass upon volume, that is amount of mass that you have in a given volume, will be called as its density. So density is here becomes very high. You can say that even at the point of its singularity, it is tending to infinity. What is singularity? We'll have a discussion on it. So mass is very high, volume is very low. So that's why this figure itself, this density is very high. And that's why the stars which are not that massive, or if we talk about our sun, or even if you talk about the earth, these cannot convert into a black hole. For example, the calculations show that if earth was to convert into a black hole, then in that case the diameter of the earth should have been just 8 millimeters. If the diameter of the earth was 8 millimeters, then earth stood a chance to convert into a black hole. But of course it's not 8 millimeters, it's much more than that, right? So that's why earth cannot convert into a black hole. Our sun cannot convert into a black hole. Only massive stars can convert into a black hole. So the density will be very high. At the same time, what we discussed is that black holes are invisible due to extreme gravity, but global effort under Event Horizon Telescope program captured the first image of a black hole called M87 in 2019. M here stands for Messier. So going back to this image, this was the image that was captured. Now what is this image? Because we are saying light cannot escape black hole, and if light cannot escape, how is light capturing the black hole? The answer to this is that this is not the black hole itself, but rather the event horizon of the black hole. What do we mean by event horizon? Just look at this picture. If you observe this picture, you have different regions of a black hole. You have ergosphere, you have event horizon, and you have singularity. These three terms are very important. First of all, ergosphere. What is ergosphere? When an object is near black hole, first of all, what we know that these objects will start to fall towards the black hole, right? Fall towards the center of the black hole. Even this is true for all the electromagnetic waves which are in the vicinity. So everything in the vicinity will start to fall towards the black hole. After that, there is one more region that we have. This region is called as ergosphere. Once any object enters the ergosphere, this will start to rotate in a direction which is being taken as a direction of rotation by the black hole. Let's say this is the direction of rotation of the black hole. Then in that case, as soon as these objects fall, as soon as these objects enter the ergosphere, they will also start to rotate in the same direction. So this is the meaning of ergosphere. This is the significance of this particular region, which is called as ergosphere. Then after that comes event horizon. Event horizon is the part of the black hole after which nothing can escape the black hole. That is, if you see light, or whatever we observed in the image that we saw just 2-3 minutes back, what you observe there is the light which is in the vicinity of the event horizon. Once you have entered inside the event horizon, then after that nothing can escape. Then after that it's complete darkness. If you go back and if I show you the same image, the mid part that you see, this mid part is still dark, right? This is still dark. Why? Because you have entered inside the event horizon. So this is the significance of event horizon. Once you have entered inside event horizon, after that nothing can escape the black hole. Not even light can escape the black hole. So this is the significance of the event horizon. Then after that you have one more region that you saw, and this is called as singularity. What is singularity? Singularity is the point in a black hole where the region is very small and all the objects, everything in the vicinity that was there, all the celestial bodies, all the minor objects in space, everything is now concentrated in this very tiny volume. We discussed about the Big Bang theory as well. In Big Bang theory also, when we discussed about the first single particle, the particle that was smaller than the size of a proton, as we said, this is also singularity. But there's a difference between the singularity that we discussed at the time of Big Bang and the singularity that we are talking about here for a black hole, because this point is not as small as the point that we discussed for the formation of the black hole. That's why many a times this is also called as gravitational singularity. This point is also called as gravitational singularity because this has been caused because of gravitation. So singularity meaning simply that you have a very small region where all the matter, all the objects are concentrated in a very small space. And that's why the mass here will be very high and volume is very low, and that's why we are saying that density of this region will be very high, even tending to infinity, we can say, while you are at singularity. So this is brief discussion about black hole. Now one more important thing is going back to what we discussed here about the first image of the black hole, because this was a very significant development. April 2019, this image being captured for the first time for a given black hole. Now what we are saying is that it is the event horizon. What was captured was the event horizon of the black hole. Here the name event horizon is also very important because the name of the telescope that captured the black hole was Event Horizon Telescope. Now just understand that when we talk about Event Horizon Telescope, this is not one single optical or radio telescope, but rather this is a group of telescopes. Group of telescopes, some of which are located in the US, some of which are located in Antarctica and at other places on the earth. So what they are trying to do is, through this telescope, they are trying to build a virtual network of aperture, and this aperture, when you combine everything, this aperture becomes very large, and because of this very large aperture, it was able to capture event horizon of the black hole. Now what do we mean by this term that I am saying, aperture? The meaning of aperture is very simple. This is basically nothing but the region that collects light. So when we are talking about the aperture of a telescope, we are talking about the region that will collect light. So what Event Horizon Telescope program was trying to do is that it is having a set of many small telescopes placed at different regions on the earth, and together they are building an aperture, a virtual aperture, which is very large. So that's why it will be able to capture light much more than a normal telescope. At the same time, if you want, you can also note down the name of the process or the mechanism that is used to capture the image of a very far away object like this. This is called as VLBI, which basically stands for Very Long Baseline Interferometry. This is what it basically stands for. So this is the phenomena where so many apertures are together being taken and a virtual aperture, very large aperture, is being formed so that more light can be captured. This was the mechanism that was used by the Event Horizon Telescope to capture this first black hole. So these are few things that you should know about